Welcome to the Balancing Forces Unit Internalization video. My name is Sean Tamarisk of KIPP, Massachusetts. Wyman Koo of KIPP NYC also created supporting materials for this unit. Our big unit question is, how can an object start moving or stop moving without anything touching it? And the anchor phenomena that students use to explore this idea is that of a floating train, a magnetic train. Students begin the unit by watching a video of the floating train, and throughout the unit, they attempt to describe how exactly it is that this train can rise up from the tracks, move forward along the tracks, and then move back down onto the tracks again, using increasingly complex explanations of forces and magnets and so forth as they progress through the unit. So before we begin, please make sure that you have done these three things. This unit's important because it serves as an introduction to forces and a lot of the foundational concepts of physics. Students begin to understand that nothing can move without a force, move or change without a force acting on it. Later on, students solidify their understanding of forces by studying Newton's three laws of motion, and this allows them to look at more complex phenomena such as flying objects. So again, this unit's an important foundation for a lot of study later on in physics. Students also use magnets extensively in this unit and learn about the basics of magnetism. They watch a demonstration of an electromagnet and understand how they can be applied in engineering. Magnets form the basis of a lot of electronics and circuitry, so this is an important foundational concept as well. All right, on to our chapter overviews. We begin the unit asking our first big question: what makes an object start to move? And the goal is for students to be able to describe the maglev train as it rises off of the tracks. It goes from non-moving on the tracks to rising above it, moving. Students read the book Forces All Around to recognize that forces are all pushes or pulls and to recognize forces around them in the real world. Students investigate a variety of materials to see how they can get those materials to be pushed or pulled.
Students investigate which materials are attracted to magnets and which are not, and the results are sometimes surprising.
They read the book What My Sister Taught Me About Magnets to help solidify some of these concepts and to introduce the idea of north and south poles on the magnet.
Students also investigate how magnets attract and repel one another and attempt to model and diagram the forces that are working between magnets
by diagramming two ring magnets as they come together and are repelled apart. By the end of these lessons, students should understand the fundamentals of Progress Build 1, shown here. Take a second to pause the video and read it. And in the first focus task, students come back to the phenomena of the floating train. Their task is to diagram how they think the train rises above the tracks, then to make a claim about what is happening, and finally support that claim with evidence and explanation. Go ahead and pause the video and complete the task. Note that there's a word bank as well as a writing checklist to help support you as you're writing. So here's an exemplar diagram. Let's take a minute to look at it. What makes it exemplary? First of all, a student has drawn magnets on either side of the train, and importantly, they've labeled those magnets with north and south poles, the north poles repelling one another here and here. They've also drawn arrows to show that the forces are pushing the train up. Go ahead and read the exemplar response down here and compare it to your own. Pause the video. Great. You should have also marked D for the claim. Finally, go ahead and check the scoring guide to get an idea for how you're going to be scoring students on their responses. All right, on to big question number 2. What makes an object fall? Now, we go back to the floating train video and notice that at the end of the video, the train falls back down towards the earth, falls back down towards the tracks. So that's our phenomena that we're going to be investigating and trying to understand more about. Students read the book Handbook of Forces and read more specifically about gravity and how all objects are attracted towards the center of the earth. Students also learn about electromagnets in this section because this will be an important part of their explanation of the train. The train won't be able to come back down to the tracks if the magnets are still repelling each other. So there must be a way that the magnets are switched off. The solution is an electromagnet, which is a human-made magnet. A magnetic field that's created by wrapping copper wire around something and then sending electrons through it. For example, with this battery and nail here is attracting the paper clips down here. Electromagnets are used in scrap yards on cranes to move metal around. Students also investigate chain reactions and diagram the forces, including gravity, that are happening in a chain reaction. By the end of these lessons, students should understand Progress Build 2. Take a second to pause the video and read it here. Now we revisit the train and attempt to explain how it falls back down to the tracks. Go ahead and pause the video and take a few minutes to construct an explanation. Once again, you've got a writing checklist and a word bank to support your writing. All right, let's take a look at this here exemplar. Note that now there are arrows showing the train moving down, being pulled down by gravity, of the force of gravity. And the magnets are clearly off in this diagram. The only thing I would add maybe is a label electromagnets to make it clear that these are magnets that are being turned on and off. Go ahead and take a minute to read the exemplar response and compare it to your own. Then check the scoring guide to see other ways that students can get credit for this assignment. Pause now. And on to big question number 3. Why do some objects float instead of fall? Once again, we come back to the floating train now and focus on what forces are causing it to float above the track for most of its journey.
To answer this big question, students will return to investigating magnets and create a little demonstration here of how you can get a magnet to float in the air, using another magnet underneath with the same poles facing each other on the same side, causing the magnets to repel.
Students model an object floating by creating a floating paperclip device, where a paperclip is pulled up by a magnet so it appears to float above the cardboard. Students conduct this demonstration and attempt to diagram the forces at work that cause the paperclip to float. Students read the text explaining a bridge, which is an opportunity for them to apply what they're starting to learn about balanced and unbalanced forces to a bridge, recognizing that as long as forces are balanced, an object such as a bridge doesn't move. Students also read the textbook hoverboard, again to better understand that when forces are balanced, objects don't move, but when forces are unbalanced, objects start to move. This is also where students talk about repeated patterns of motion, that is, being able to predict how an object is going to move based upon patterns of movement that have been observed in the past. For example, guessing that a bicycle wheel will continue to roll forward in this spiral pattern, or that a swing will continue to move back and forth. So this is an important opportunity to develop the cross-cutting idea of patterns and how we can use patterns to make predictions about the future. Ultimately, these lessons prepare students to understand Progress Build 4, outlined here. Take a second to pause and read it carefully. We assess Progress Build 3 by returning to the floating train and diagramming how it's actually able to float above the tracks. Take a few minutes to write your explanation, again remembering to use the checklist and the word bank as supports. Go ahead and pause now. And once again, we've got an exemplar here. Note that it shows multiple forces at work on the train, both the repelling upward forces of magnetism and the pulling non-contact downward force of gravity. When the train is floating, these forces are balanced, so the train is not moving. Notice that we've got everything labeled in our diagram. Take a minute to read the exemplar response down here, and then check the scoring guide to see what elements that response needs to include to get full credit. Go ahead and pause now. All right, we're now ready for the end of unit assessment. Ideally, you should use students' work throughout the unit to reteach critical concepts to ensure kids are totally ready to show what they know on the end of the unit assessment. The assessment is organized by Progress Build question. Number 3, for example, assesses Progress Build 1. Take a minute to complete this question, then check back here. Great, here's the answers. Each of these things that is a force is an example of something starting to move, and they can be either touching or non-touching. Let's take a look at this Progress Build 2 question. Here we have a patterns of motion question, where students are swinging on the swing. Take a second to answer this one. And the correct answer is C, and there is Progress Build 2 to the right for you to refer to. On to Progress Build 3 question. Take a minute or two to answer this multi-part question. And the correct answer is A. Because the steel crate is not moving, the forces must be balanced. Gravity pulling the box down and the ground pushing the box up, canceling each other out. Well, that's it for our video. Thank you so much for taking the time to prepare and internalize this unit and be ready to teach it for your students. For KIPP teachers, and I recommend this for everyone else as well, take the rest of the end of unit assessment so you know what kids are expected to know. Complete the unit internalization guide. And then for KIPP folks, submit the unit Google form on kipste.org to send your responses to your coach. Then finish out the rest of these tasks here to be completely ready to teach this unit to your kiddos. Thanks again.
Here's a little bonus fun. You'll notice the Amplify unit doesn't actually talk about why would we have a floating train in the first place. The reason being that having it up on magnets cuts down on friction and thus requires a lot less energy to move it and enables it to move much faster and much more smoothly. But it's a lot of fun to try and experiment and create your own maglev or magnetic train. It's a lot harder than I thought it would be. I took my my childhood train, my wooden train set, stuck the Amplify ring magnets on the bottom of it, and created a little track here with an angled magnets to see if I could just have it float above the track. Fortunately, when you put it there, it doesn't quite work. It'll try and stick to the sides and everything like that. The magnetic interactions with the ring magnets are a little too complex, but if you get some rectangular magnets, you can do some pretty cool things, as you see in these videos. You can Google maglev train project or maglev train DIY and find all sorts of ways that folks have done this sort of project. Be a great science fair project for some of your kids, or a classroom demonstration to show the importance of cutting down on friction.